Bismillahirrahmanirrahim, guys. How are you? Now I'm going to deliver, today I'm going to deliver a lecture on paper chromatography. It's very important type of the chromatography. And we will discuss in detail this topic. And basically, paper chromatography is an important and useful type of partition chromatography. As you studied in earlier lecture, that partition chromatography means the chromatography in which the stationary phase is liquid and the components of mixture distribute themselves between stationary phase and mobile phase. In paper chromatography, the stationary phase is basically liquid. It is basically made up of water molecules. As you know that in paper chromatography, we use a cellulose paper, which is called Wortmann filter paper number one. This cellulose paper contains the network of various cellulosic network, and the water is trapped into this cellulosic network, or you can say absorbed in this cellulosic network. This trapped water act as a stationary phase, while the paper itself act as a support to the stationary phase. While the mobile phase can be a solvent, it can be a single solvent or it can be a mixture of different solvents, which can be or which must be miscible into each other. The mobile phase can also be called as developing solvent. So that's very clear in paper chromatography. The stationary phase is water, which is absorbed on the surface of cellulosic paper uh, and which is absorbed inside the surface of the cellulosic paper, and the mobile phase is a solvent which is called developing solvent. It may be a single solvent or it may be a mixture of various solvents. So the separation of the components of mixture takes place through partition. Means that the components of mixture distribute themselves into two phases, which have more affinity to the stationary phase, they lag behind, and which have more affinity with the mobile phase will move forward. So the separation will take place. Here we must keep one thing in our mind, that the in paper chromatography, the solvent or the mobile phase travels through capillary action inside the paper. As in paper, there are so many capillaries, as the cellulose have zigzag network, so capillaries are generated, and solvent or the mobile phase tries to fill the capillaries and moves upward or downward or any other direction on the paper. So in paper chromatography, mobile travels by capillary action through the paper. Now, in next slide, we will discuss that there are three types of paper chromatography, or there maybe you can say the fourth type is also there, which is a special type of paper chromatography. And all these types depend upon the way the solvent flows or travels on the paper. For example, there is a type ascending paper chromatography, descending paper chromatography, radial paper chromatography, and next one is the two-dimensional paper chromatography. In ascending paper chromatography, mobile phase move from down to up. Moves, it means that the mobile phase moves from down to up direction. While in descending paper chromatography, mobile phase moves from up to down direction. And in radial paper chromatography, mobile phase moves horizontally along the circular paper. I show you the diagrams of these three types of paper chromatography. You can see here, this is ascending paper chromatography. Here is the paper which we have hanged it into the chromatographic tank through a cotton thread and the clip. And here is the solvent, where the in this chromatography the solvent is moving from down to up direction. So the direction of solvent flow is towards upside. Therefore, it is ascending paper chromatography. In this diagram, you can see here that the solvent is present at the top, and here the solvent is moving from up to down direction. It means that the direction of the solvent flow is from up to down. Therefore, it is called as descending paper chromatography. And in this diagram, you can see here there is a circular paper. And when we keep this paper into a petri dish, then the solvent moves in horizontal direction. So it is basically, you can say, radial chromatography. And this diagram basically indicates two-dimensional paper chromatography. In this, you can see here the solvent can move in two direction, x on x-axis or on y-axis as well. But these three types, ascending, descending, and radial paper chromatography, are the common types of paper chromatography. Now we will discuss about the technique of paper chromatography. There are various steps when we do experiment through paper chromatography. The experiment or technique is very simple. There are various steps in this paper chromatography. First of all is the choice of the filter paper. We have to choose a filter paper. Then we have to prepare the solution or sample, which we have to separate, or then we have to apply the sample on the paper. Then we have to choose the solvent, a single solvent or a mixture of a solvent. Then we have to develop the chromatogram. Chromatogram is the pattern which we obtain at the end of the experiment. And then we have to dry the paper. Then we have to locate the substances on the paper. If they are not colorful or they are colorless, we have to locate them through different locating agents. And then after that, we have to measure RF value, which is called as quantitative estimation. RF value means rate of flow, or you can say retardation force. Simply, retardation force will tell us that which component has more affinity with the stationary or which one has the more affinity with the mobile phase. We will discuss all these steps one by one. First of all, you can again see the diagram here. There is a sanding paper chromatography. First of all, we take a paper and we draw a line at the base of the paper, almost 1 to 2 centimeter above the paper from one side. That is called baseline. And then we apply the sample. And here is a chromatographic tank. Firstly, we take chromatographic tank and fill it with the solvent. The level of the solvent should be so that, or the paper should be dipped in such a way that the solvent line, or sorry, the baseline should be above the solvent higher line. And this is filter paper. And when the solvent moves upward, then we take some time. And when it moves to almost 75% of the length of the paper, then we draw the paper out and we draw a line to the point at which the solvent has moved. And this point is called solvent front. After that, we dry the paper and take readings. We will discuss all these steps one by one now in detail. This is basically sanding paper chromatography because the solvent is moving upward direction. A choice of the filter paper. First step is that we have to choose the filter paper. Usually the filter paper we use in the paper chromatography is Wortmann filter paper number one. Wortmann filter paper one is basically composed of various components or the compounds. It contains alpha cellulose almost 98.9%, beta cellulose 0.3 to 1%, pentosans 0.4 to 0.8%, ash containing substances 0.07 to 0.01%, and ether soluble substances 0.015 to 0.11%. So it means that that is the basically the composition of the Wortmann filter paper number one. We must keep this thing in our mind that a suitable filter paper should have the following properties. This paper should have excellent rate of movement of water. It means that the water molecules can move, or the solvent means the solvent or the mobile phase can move easily. It has a negligible difference of the movement of spot. It means that when we apply the sample on the baseline, the sample spot should not move prior to the application of the solvent. Then maximum degree and clarity of separation. Our paper should be such like that it must make proper spots after separation. If there are ambiguous spots or mixed one, then definitely there is not clarity of separation. So maximum degree and clarity of separation must be there. Most common size of paper we use is rectangular paper we use, although square paper can also be used. And the length of the paper we use is about 15 to 30 centimeter. And the width is almost few centimeters. So that is the ideal filter paper, which is called as Wortmann filter paper number one. Then preparation of the solution means the solution of the sample. Choice of proper solvent is required for making sample solution, and it is very important step. In fact, the solvent which is required for the making of the sample basically depends upon the type of the sample. In generally, if our sample is polar, or our sample contain polar solutes, then we have to use polar solvents. And if our sample contains non-polar solutes, then we have to use non-polar solvents for these solutes or the sample components. After that, pure solutions are made, and these pure solutions are directly applied to the filter paper. Okay, so we have to make the pure solutions into suitable solvents. If our sample has biological tissues, they must be treated firstly with suitable solvent, and these must be extracted. Their extracts must be obtained because in biological tissues, large number of proteins and salts are present, and they may interfere with the partition process. So we have to do extraction, and we have to do the mixture of extract the mixture of amino acids we want to separate. Okay, so that is basically the extraction process before applying the sample on the paper. So proteins which are present in the biological tissues can be removed by ion exchange, resin, or electrolytic methods. Okay, so that is the prior process in case of proteins. In case of proteins, if we want to separate proteins or amino acids from biological tissues, we have to make the sample through all these steps. But if we want to make a general separation, or for example, if we want to separate the separation of mixture of ink or the mixture of metals, then we have to dissolve the solute into proper solvent, and that is basically the sample. Now, after that, after making the sample, we have to apply the sample on the filter paper. So, to apply the sample on the filter paper, we need basically a platinum loop. But platinum loop is used when we have to do qualitative experimentation or qualitative analysis. It is basically used preferably, platinum loop for applying the sample is used preferably because it can be used again and again carefully by carefully washing and heating it strongly. We can apply or we can use platinum loop again and again. The second option is micropipettes and microsyringes. Micropipettes and microsyringes are also available, which are of very small size, and they can be used for qualitative as well as quantitative purposes. And the third option is the use of capillary tubes. Capillary tubes can also be used to apply the sample on the baseline or on the paper. Now we go forward. Choice of the solvent. Now I'm talking with the solvent which is used as a mobile phase. The some of the important point we must consider after before we want to choose the solvent is the nature of the solvent is very important in the whole development process of the chromatogram development. So the solvent should be free from impurity, and it should be dried before use. If the solvent is not water, we have to remove moisture from it. Polar solvents such as water is adsorbed by the paper and held stationary, whereas less polar solvents such as ethanol, acetone, glycerol, glycol, acids, and amines flow through easily. So we cannot use water single water as a solvent. If we are using water as a solvent or as a mobile phase, we have to use another liquid as well. Or you can say that we have to use the combinations. Water alone cannot be used as a mobile phase because in paper chromatography, water is acting as a stationary phase. So water alone cannot be used as a mobile phase. Although pure solvents are used, but mixture of solvents can also be used. But the solvent should have the following properties. The anyhow the solvent, whichever the solvent which we are using, should have the following properties. The solvent should not chemically react with any of the component of the mixture. Okay, that is the first important point. Secondly, the composition of the solvents remains same throughout the end of the experiment. It means that throughout the experiment, the mixture component, or sorry, the composition of the solvent, if you are taking the various solvents in a certain ratio, the ratio should remain the same. It should not change. The solvent should not interfere with the detection of the spots. That is the third requirement. And the best solvents are those which basically produce RF values in the range of 0.05 to zero point 0.1. So the best solvents are those which produce this RF value differences. So we have various solvents in this process, and we can take the solvents according to the nature of the solute. What is the process of development of chromatogram? As I told you, after the uh, paper is hanged into the chromatographic tank and the solvent moves up to 75% of the total length of the paper, then after that paper is drawn out of the chromatographic tank, and the important thing is to locate the components of the mixture. And after locating the components of the mixture, we get a pattern which is called chromatogram. The development of chromatogram basically depends upon the accuracy of the previous steps. It means that if we have chosen best solvents, best mobile phase, we have applied the sample properly, and we have given the time properly, we have hanged paper properly, we have developed, we can develop better chromatogram through all these processes. So the accuracy of the chromatogram depends upon the previous steps. After development of the chromatogram, we have to dry it, and for it we can use dryer, or we can use it we can dry it in open environment at room temperature. Before drying the paper, we must mark the solvent front. Solvent front is the line up to which the solvent have moved on the paper. So that because when we have to calculate RF value, we need the value of the, we need to know about the solvent front. So before drying the paper, you must mark the solvent front. After that, if you have to liquid the substances, for example, you have developed the chromatogram, but there is no spot, there is no color on the chromatogram. It means that the components are colorless. So you have to convert the colorless components into colorful complexes, or colorful derivatives. Or you have to locate through other methods as well. For this, we have three methods. If the samples are visible, then we can directly calculate RF values. But if they are not visible, their spots are colorless. So we have to develop we have to use various methods to locate these spots. These methods can be physical methods, these can be chemical methods, or these can be radioactive methods. In physical methods, we basically do not use any chemical, and the physical methods are more beneficial and more better than the chemical methods, because in physical methods there is no interaction of the separated components with any other chemical, or there is no complex formation. So the component remain in their pure chemical state. So in physical method, we can use UV lamp, or we can use ordinary light as a locator to locate the spots. So these are the physical methods. In chemical methods, we use certain chemicals. We spray various chemicals which are called as locating reagents or locating agents. For example, if we have to locate amino acids on the separation, so you have to use ninhydrin. You have to spray ninhydrin on the paper, because ninhydrin makes purple color complexes or blue color complexes with amino acids. So ninhydrin is basically a locating agent for amino acids. So in chemical methods, we never use physical methods. We use chemical methods. We use various reagents that can locate the components which have been separated on the paper. These locating agents are reagents which basically makes a color complexes, or react with the component and make a colorful compound. These ligating agents can be sprayed on the paper, or you can say the paper can be dipped into the solution of the locating agents. Now I am going to give you example of the locating agents. If, for example, we have to locate metals, various metals, we can use rubinic acid, diphenyl carbazide, and ammonium sulfide. If we have to locate various amino acids, we can use ninhydrin, isotin, Sakaguchi as a locating agent. And if you have to locate various sugar complexes or molecules, we can use silver nitrate, aniline, and N-acetaldehyde as a locating agent. The third method is basically radioactive method. In this method, the substances or can be located by using radiations, but these methods are rarely used. After that, we have to study about retardation factor or RF value. Retardation factor or RF value is basically the rate at which the solute has moved. And this rate can be determined with the help of RF value. The retardation factor we can define is as the ratio of the distance traveled by the component from the baseline to the distance traveled by the solvent from baseline. For example, RF value, if we want to calculate RF value, we have to divide the distance traveled by the component from baseline to the distance traveled by the solvent from baseline. RF value can vary from 0 to 1. It can vary from 0 to 1. It has no unit as well. There are four factors upon which RF value depends. For example, nature of the paper, solvent system, nature of sample, and development process which we have used in the separation. For example, on this paper, I tried to explain you how we can calculate RF value. For example, if we have a mixture which have two components, A and B, okay, and this is baseline, and we dip the paper, and after drawing out the paper, we mark this line which is solvent front. If we, for example, want to calculate the RF value of A, we have to measure the distance of the solvent moved from baseline. This is called solvent front, and we have to measure the distance moved by the component A from baseline. So RF value should be, or RF value can be, this distance is basically 4 centimeter, and this distance is 10 centimeter. So the RF value of A is 4 over 10. It means the distance traveled by the component A from baseline divided by the distance traveled by the solvent from baseline. Okay. So this value is 0.4. RF values for A is 0.4. And if we want to calculate the RF value of B component, the distance traveled by the B component is 8 centimeter and the distance traveled by the solvent is 10 centimeter. So RF value of B is 8 divided by 10, that is equal to 0.8. So this is how we can calculate RF values of various components. Lesser the RF value means that the greater the affinity with the stationary phase. Okay, and greater the RF value means the greater the affinity with the mobile phase. After that, there are some applications of, lastly, we will discuss about the application of chromatography. It can be used in the identification of trace metals in ores. It can be used for the identification of cobalt, nickel, and zinc. It can be used to check the purity of pharmaceutical and fermentation products. It can be used to separate the mixture of pesticides like dichloro, diphenyl, trichloroethane, benzene, hexachloride, heptachlor, endrine, and aldrine, वगैरह. It can also be used for the specification of various anions like sulfur, sulfide, thiosulfate, and sulfate as well. It can also be used for the detection of adulterants which are present or contaminants which are present in the food or drinks, or it can be used for the separation of amino acids. So this is all about the chromatography. Thank you so much. God bless you.